Hi, welcome to another video on my Raspberry Pi 1 using hardware pulse width modulation with use of DMA, direct memory access. Last time I tried to get fischertechnik pulse width modulation motor running using RPIO and the hardware pulse width modulation, and that doesn't work yet. Now, looking at this output, it says a pulse width increment with 10 microseconds. 10 microseconds is equivalent of a period of 10 microseconds is equivalent with a frequency of 100 kilohertz. And that is way beyond the activity of the motor. If you look at the pulse, then you see 8, but 8 watt, 8 centimeters, 8 seconds, 8 watt, I don't know. So I want to measure that somehow, but if this is indeed a very high frequency, a too high frequency in fact, then I can't measure this because my multimeter has thresholds of 20 kilohertz and 200 kilohertz and beyond, and actually how far it goes beyond that I'm not really sure. I didn't try. But another problem is that as you can see with this, it just runs and ends. So I have to say it needs to be cleaned. That is at first, but apart from that, it has to be run, and after running, while running, I can see and I can measure. So actually using the while loop, I could try something. While always true, and since this is Python, I am going to do it this way. So now we have a while loop, save it, go for it, and now I can do a measurement, and I will do this measurement right on the motor, and it says there's a frequency of almost 5 kilohertz. So 5 kilohertz is way too you would say that 5 kilohertz is way too high for this motor. However, a test has also shown, not on the Raspberry Pi by the way, that 26 kilohertz is already is still making the motor run. So the question is how to do this. So I'm quitting this one and I'm changing it to a very different pulse width. Let me do it a little bit different. I have to write the frequency down. So with this pulse width I am at 4.9. So next attempt is say 16. What will this be? And the pulse width is 3.8. So an increase of the pulse width brings down the frequency. Now that is of course interesting to know. So let's get further. So with this knowledge I will go try some other width, and I double it for now. And see what frequency this gives, and measuring again right at the motor. And it fluctuates, the frequency fluctuates between nothing and 3.5, 4.3. And with this fluctuation it is very difficult to measure anything at all. But given the first result of 3.8, it's rather difficult to find out what it really is. So let's stop this and see if the pulse width of 16 can be repeated as being steady. And now that I hold the probe to the motor, it proves to be not steady at all. So that is going to be difficult. Is it steady at 8 then? I'm afraid not, but let's see. And this is remarkably stable. It fluctuates between 2.9 and 3.8. So why are the others fluctuating even more? That's difficult to say. But what is the pulse width anyway? A pulse width is 1 up, and yes, pulse width is, if you can see a block form in your mind, then the pulse is 1 up, and then when the pulse goes down it is not counted, as far as I've understood. So I think I have to investigate a bit further. Because if you have here, this is duty cycle 0 and this is 25. So if you have a pulse, assuming that this is a pulse width 25, then the pulse width of 8 is very small. When you have a pulse width of 100, then you have something full. Now this is with Arduino, not with RaspberryPi, but then again this is the idea of pulse width. So this is the pulse and this isn't, because this is 0 volts. So what would it be if I say pulse width is 0? Then you would have nothing. So let's go here and fill in 0, I should not measure anything. And let's measure something. Let's put the multimeter to volts DC, and it indeed measures nothing, 0 volts. So I am going to once again back to 8, and I have to stop this first. So this is 8 again. Holding the volts probe ground to the ground, measuring at the motor. It says also 0, but when I put it then to frequency, it says absolutely nothing. And I lose the ground probe and it says 9 kilohertz and no fluctuation. And I'm at a width of 8. This is rather strange. No consistency. Very strange. When you think of it, watching this schedule, this graph, it is actually quite logical that I don't measure any voltage at with a pulse width of 8, because considering that this is the pulse width, then with 0 duty cycle you get 0 volts. Then the voltage that I get from the Raspberry Pi is 5 volts at the moment. But when I put it to 50, the pulse width, then I have half of the 5 volts would be 2.5 volts. When I give it 100% pulse width, then it would be 5 volts. So let's try to 25, no, 50, then I would be getting 2.5 volts, should be getting, if my theory is correct. So let's just do that. And it's set to frequency right now. Let me measure the frequency. It's fluctuating to 7 kilohertz now, and going to volts, and then I have it to put it to 20 because 5 volts is of course larger, or 2.5 volts is larger than 2. So let's measure that. However, it doesn't show anything, so that is rather weird with a pulse width. I didn't expect this to happen. Nothing at all. So if my theory is then incorrect, considering this one, then what would it be? And I'm not even looking at whether the motor is going to run, because that still complies to the range of 30 Hz to let's say 120 Hz. Given that, if you look at let's go back. Yeah, it goes too far, but it says 10 microseconds, and 10 microseconds is 1 to the mean 1 to the power minus 5 is equivalent to 100 kilohertz. So I should get it. I should get a change there. Question is how to accomplish that, because here I can't set a time. I can't set anything, and the the microsecond is set right after this, and this is just setting a pulse width. Alright, setting a pulse width to 150. And I'm just trying anything, going back to frequency to 20. I'm measuring. It says again 6 kilohertz. Quite stable actually. 6.9, 6.8, 6.9. So that is higher up if I look at it. So what about a lower pulse width of 2? Again, frequency measurement. If I don't lose the probe. So frequency measurement right at the motor, which says 30 hertz. That was quite low actually. It fluctuates between 3 kilohertz and 600 hertz or 300 hertz even. Goes down to 100 hertz. So if I take a pulse width of even lower than 1, what would that be? Is that even possible? That's an interesting thought. So with that conclusion, let's try a broken number, a float, if that would be possible. So I go to 0.5. What would that be? Integer argument expected. Okay. That is too bad. So going to 1, measuring again on the motor. 200 hertz. Fluctuating from 200 hertz to 4 kilohertz, which is quite a range actually. So how to get a very low frequency here? That is a very interesting thing. Does it depend on the channel, because it opens just channel 0? Does it depend on the GPIO? One way to find out is to look further at it, because this way it doesn't look like I'm going to be making any progress. I've measured from 1 to 32, and all I get is a frequency range from 300 Hertz to 7 to 8 kilohertz. And although experiments have proven that the motor will run on even 26,000 Hertz, 26 kilohertz, it doesn't run. The motor does not run at all. So what is the difference? Is the difference that it lacks a transistor? Is that really it? Because with the other experiments it actually has a transistor in between, and here it does not. So I'm inclined to put a transistor in between the PWM feed and the motor. And I think I just will do just that. So I am going to use this open piece of breadboard and put this jump wire right here. It is the minus to this transistor, which goes right here. We should go right there. Oops. This should go better. Way better. Then I need a resistor in front of it. So there's a resistor. Then from here I take the pulse width modulation, and from here I take the motor. So that will now go here, and that is the situation as I want it. So in very short, pulse width modulation via transistor to the base of the transistor. Then at the collector I'm setting the motor, and to the emitter if I am entirely correct, and this one goes to the MOS. And this setup should be running, and of course this part of the motor is still going to the MOS, and MOS is ground. So right now when I start the program, there should be a motor running. So let's see if that actually does work. This does not work, and I change the value to say 8 as it was originally. Still absolutely nothing. Now let me change the value to 50. and still do nothing. So now there is a timing sleep timer, but since I'm in a while loop, I can remove that sleep for now and try how that works. Still nothing. I go to 150 and the 150 gave a nice result in the frequency, but how will it work here? And it still doesn't do anything. So the question is, does this motor work anyway? I do think so. The question is, how exactly? I have no idea what to do else. I can of course do some measurements. So to that end I put my multimeter on again. And let's see if I get it in view. Not quite sure if you can see something on camera. Anyway, I'm starting the program and I'm going to measure. And this is not supposed to measure anything, so this is a bit odd. Let me, yeah, it is measuring something, but this is now measuring 12 kilohertz. If I measure with this one, it says 9, well 9 or 12, whatever. This is 11 kilohertz, and in the other thing it says, well, then it just runs, so I have no clue now. So this was an experiment or series of experiments with not entirely satisfactory results. Changing the pulse width hasn't shown much of a result. Going for 300 Hz to even 12 Hz, 12 kilohertz I mean. How it exactly goes, I'm not sure yet. I also don't entirely trust the multimeter, because I don't think that a frequency changes that much. Once you have set the pulse width, you have a frequency, and then you can't have fluctuating frequencies with one pulse width. So I rather doubt that is correct. Then adding some electronics, like I have done in other experiments, hasn't shown any progress as well, or either. I have used the same type of a transistor, a normal resistor. It's grounded, put to earth, so to say. Input to the transistor is pulse width modulation. Output from the transistor is the motor, which is also connected to the ground. That should be working. And why it doesn't work, I should be testing the motor of course, but given previous results I don't doubt that it is working. I am going to find out more about this hardware pulse width modulation, how it exactly works. This value of 150 doesn't do anything either, which is surprising, but I still hope that the change to hardware pulse width modulation will be better than software pulse width modulation that I used previously and does work on an LED. So with that said, thank you for watching. If you like my videos and haven't subscribed yet to my channel, please do so. Also check out my Instagram with nice pictures, and this is certainly going to be continued. If you like to donate to keep my blog alive, see for more information my website, which is shown at the start of the video and which is listed under this video. Thank you and bye bye.